Namaste. Khush raho betiya. I, JVN Dr. Y. Chandrakala, Assistant Professor, Jyoti Vidyapeeth, Women's University, Jaipur. In today's class, we will be going to discuss on energy balance. Okay. So, unlike many chemical processes, bioprocesses are not particularly energy intensive. Okay. So, the fermenter and the enzyme reactors are operated at temperature and the pressure close to the ambient energy input. Okay. For a downstream processing is minimized to avoid a damaging heat liable product. Okay. So nevertheless, here the energy effects are important because the biological catalysts are very sensitive to heat and change in temperature. Okay. So in large scale process, heat released during the reactions are caused cell death or denaturation of the enzymes. Okay? If it is not removed quickly. So, for rational designs of the temperature control facilities, energy flow in the system must be determined by using the energy balance. Okay? So the energy effects are also important in other areas like bioprocessing such as stream sterilization when we are doing. So we have to keep an energy balance here. Otherwise the cell death or denaturation of the enzymes will take place. So the law of conservation of energy means here the energy accounting a system can be set up, determine the amount of steam or cooling water requires to minimize the optimization process of temperature. Okay. So when we see in thermodynamic concept are explained as an energy conversion of the equation applicable to the biological process is derived. Okay. So how actually this energy conversion is when relating to the biological concept. So the basic energy concept we can say the energy takes three forms. One is kinetic energy, second potential energy, and third is the internal energy. So kinetic energy is the energy possessed by a moving system because of its velocity. Okay. So kinetic energy is the energy processed by a moving system because of its velocity. Okay. So potential energy is due to the position of the system in a gravitational or electrostatic field. Okay. Or due to the conformation of the system relative to the equilibrium position. Okay. So third is the internal energy. So internal energy, when we see, it is the sum of all molecular, atomic and subatomic energies of matter. Okay. So the internal energy cannot be measured directly or known in absolute terms. Okay. So we can only quantify change of the internal energy. Okay. So the energy is transferred is either heat or work, which we have already discussed in our last class about the heat or work. Heat is the energy that flows across the system boundaries because of the temperature difference between the system and surrounding. Okay. So work is the energy transferred as a result of any driving force then other than the temperature difference. Okay. So there are two types of work, shaft work, or which is the work done by moving part within the system. Okay. That is, for example, mixing of for fermentation broth. Okay. Or flow work, it is the denoted by W F, and the energy required to push the matter into the system. Okay. So in a flow through process, the fluid at the inlet at work done on by the fluid just outside the system. So here the energy transferred as the energy either heat or work. Okay. So heat is the energy that flows across the system of the boundaries because of the temperature difference in the system. Okay. And the surrounding. And the work is the energy transferred as a result of different driving force other than the temperature. Okay. So two types of work, that is shaft work and flow work. Shaft work, it is the work which is done by moving the part within the system, or it is used for mixing the fermentation broth. Okay. And the flow work, it is the energy required to push the matter into the system. Okay. So in a flow, there through the process, the fluid at the inlet has work done by the fluid just outside the system. Okay, while the fluid at the outlet does work on the fluid in front of the push or flow along. Okay, so the flow work is given by the expression of like WF is equal to PV. Okay. Where P is the pressure and V is the volume. Okay. So the unit, SI unit for energy is the joule, and J is to 1 and is equal to Newton meter. Okay. Intensive and extensive properties. Properties of the matter falls into the two categories, those which magnitude depend on the quantity of matter present in those which magnitude does not. Okay. Temperature, density, or the mole fractions are the examples we can say of the property that depends on the size of the system. Okay. So extensive variable can be converted to specific quantity by dividing the mass. For example, specific volume is the volume divided by mass. Okay. So therefore, internal energy we can denote by the mu, and internal energy we can say it is the quantity per unit mass. Okay. Thank you. This session is powered by 2.0 Jyoti Vidyapeeth Women's University, Jaipur. Hope you are satisfied with my session. If you have any queries, please write down in the comment box. I will resolve it in the problem solving session. Thank you.